Hello, this is Mrs. DB, and today we are going to talk about transformations. This is an introduction to transformations. Some of you may have looked at them in Algebra 1, but many of you maybe this will be your first time seeing it. So we are going to look at different kinds of transformations, including reflections, rotations, and translations, and we're also going to graph them in the coordinate plane. Our vocabulary today is transformation. We just talked about what that was. It's when you change a figure, either by reflecting it, rotating it, or translating it. You can also do transformations by changing their size by a dilation or a stretch or a shrink, but we're not going to talk about those in this section. So the ones we're going to talk about is reflections, that's flipping it over a line, like when you look in a mirror. A rotation is when you spin it, and a translation is just when you move it. Before your original figure is called the pre-image, before you change it at all, and the image is what you get after you transform it. Here's an example that there's many kinds. This is in your book, this picture, that there's lots of transformations when you look at a rug or a floor covering or wall coverings. There's usually transformations that take place. And here's another way of the formal definitions of these words here. The original figure is the pre-image, the resulting figure is called the image. A transformation maps the pre-image to the image, and you use this arrow to show that there was a transformation. The image will get these like prime numbers after the points, the vertices of the figure. Okay, so here's what we're talking about. We've got a pre-image, this triangle here, ABC, triangle ABC, has been transformed, so that's what this arrow is showing, to triangle A prime, B prime, C prime. So all you do is put apostrophes after it. This would be a translation because we slid triangle ABC over, down, and to the right so that we ended up with triangle A prime, B prime, C prime. We didn't change the size. We didn't change the way that it was pointing. Like C is still the farthest to the right point and C prime is the farthest to the right. So we didn't change its orientation and we didn't change its size. Here's the three types of transformations we're going to talk about. A reflection is when you reflect it over a line. In this section, we'll be reflecting over either the y-axis or the x-axis. This one's reflected about the y-axis. If you folded right on this line, triangle ABC would lie exactly on top of triangle A prime, B prime, C prime. Each point in its image are the same distance from the line of reflection. A rotation is when we take a figure, in this case it was a quadrilateral, D, E, F, G, and we rotate it a certain number of degrees. And then we end up with a new figure, which is called the image, D prime, E prime, F prime, G prime. Each point and its image are the same distance from P, that point that we rotated it about. And a translation is probably the simplest one. That's sometimes called a slide, and that's when you just move every point the same distance and in the same direction. So M maybe went up 2 and to the right 6, so L went up 2 and to the right 6, and K went up 2 and to the right, and J went up 2 and to the right. So they all go the same amount each time in the same direction. All right, so our first example says to identify. We are going to name it and we're going to say how did it change, and then we'll use arrow notation to describe. So our first thing is, do we have to figure out, is this a translation? Did it slide? Is it a rotation? Did it turn? Or is it a reflection about a line? So the first thing is we're looking to see if it can be a reflection. It can't be a reflection because each point in its image are not the same distance from a line. Like, what line could I draw and then fold it over so that it would match up? There isn't any. It's not a translation because it turned. So it's a rotation. It's a rotation 90 degrees. They actually rotated about the origin. They took this triangle and they just turned it so that now it looks where the it starts with the blue triangle, and they turned it 90 degrees this way, and now it ends up where the red triangle is. And then the way you write it is you write triangle ABC, and then you put that arrow. That means it's been transformed to triangle A prime, B prime, C prime. Prime just means you put the apostrophe. Okay, this one says identify the transformation. This one has more than one thing. It says it can't be a translation because each point in its image are not in the same relative position. Now, when I first looked at this, I said, oh yeah, it could be a translation. I just moved triangle EDFG down, or EDGF down. But actually, it's not, because that would mean that this point right here would be E prime. And it's not. E is way over here, E prime. And D is way over here, and G to G prime is here. So that must mean that they must have folded it about the x-axis. They reflected it instead of translated it. So then you write these in order. D, E, F, G is transformed to D prime, E prime, F prime, G prime. And you could also say that it's a reflection about, whoops, how did I move that? About the x-axis, because that's really how they reflected it about that line right there. Okay, now try these two. Pause the video and see if you can figure out whether or not they are here's your three things again. It might be a rotation, it might be a reflection, or it might be a translation. You decide which one each of these are, and then use the arrow notation. So let's see, we usually go in alphabetical order, M, N, O, P. So you'll start with M, N, O, P, and then you'll write the arrow, and then how will you write the next part? So pause the video, try it, and then come back and check your work. Okay, so for A, you should have got that this is a translation. And you should have finished our arrow notation with M, N, O, P is transformed to M prime, N prime, O prime, P prime. And for B, did you get that this is a rotation? Because it has changed its direction. And you don't have to say what angle it's been rotated, you just have to say it is a rotation. And triangle XYZ would be transformed to triangle X prime, Y prime, Z prime. Hope you got those right. Let's look at drawing these in a coordinate plane. So they're giving us some vertices of a figure. It's got 3 vertices, so it must be a triangle. After a transformation, the image of the figure has different vertices. So you're going to draw the pre-image and the image. Remember, the pre-image is the original. So you get your graph paper out, and you plot the points A, B, and C, and then you connect them with a nice straight line. Now you can do this in Sketchpad very easily, or you can do it on your own graph paper. Then we also graphed the points for A prime, B prime, and C prime and connected those with a nice straight line. Now you need to say, how has this figure A, B, C been transformed to get A prime, B prime, C prime? So if it was a translation, it would just slide over. It doesn't look like a translation. If it was a rotation, I don't think it's a rotation. It looks to me like it's a reflection about the y-axis, or across the y-axis. So if I were to fold this right on the y-axis, these two would line up right on top of each other. Okay, here's another one to try. So you're going to sketch the vertices. Here's E, F, and G, oh, and H. So this one's going to be a quadrilateral. And then it's going to have a transformation, and they have the image vertices as well. So draw those. So just get a piece of graph paper, or in Sketchpad try these. Pause the video and then come back and check your work. And also say what the transformation is. Okay, so hopefully you gave this a shot. Here is what your figure should look like. Our pre-image is down here, it's a rectangle, and our image is up here. So it can't be a translation because it's changed, you know, the wide side is here, now it's the skinny side is the horizontal. So it's not that. It's not a reflection because then I could just fold it and it would look the same, although it might be a reflection about the line y equals x, but we aren't going to talk about that right now. So it must be a rotation. And it rotated 90 degrees to get to its new spot. So if you just said rotation, that's fine. To find the coordinates for an image of a figure after a translation, we're going to add how much to the right it goes to the x-coordinates, and we'll add how far up or down it goes to the y-coordinates. So that would be the rule. You can also, so this would be going to the right, and this would be going up. If you go to the left, you'd subtract a number. If you go down, you will subtract a number from the y-coordinate. Now, of course, you might go to the right and down, so you might have x plus a, y minus b. You don't always go to the right and up or to the left and down. You can mix and match these as you need to. So these are the rules written in like arrow notation, but that's really what you're doing. You're just adding or subtracting from the x-coordinate and from the y-coordinate, depending on what the translation is. All right, let's look at this. They're giving us the rule. They say we start with x, y. Of course, that's our coordinate of 1 point, and we want to add 2 to every x coordinate. We want to subtract 1 from every y coordinate. Well, this means that I'm going to go to the right 2, and then from the y coordinates, I'm going to go down 1. So from this point here, I'm going to go right 2 and down 1. That's where C prime will end up. And then I'll do the same thing for B. I'll go right 2 and down 1. That would be B prime. And then for A, I'd go right 2 and down 1. So A prime will be right over here. And then we connect these with nice straight lines. And this triangle, the red triangle, should look exactly the same as the blue triangle except moved. Let's see how we did. Oh, you can also do it this way. You can write the coordinates of the original, and then you can just do some math. You can do the rule, add 2 to each of the x-coordinates, and you can subtract 1 from each of your y-coordinates. If they ask you for the coordinates, that's the easiest way to do it. But you'll see that their triangle, their red triangle, ended up in the exact same place that my triangle did.